In today's lesson, we are going to look at right angle trigonometry. Now, this may be review. Well, it should technically be review because you should have looked at this in grade 10 as well as in grade 11. Now, it's not going to change too much. We are going to add kind of one new concept in, but that won't be till the next lesson. But right now, this should be review, hopefully. So one thing we want to include when we look at right angle trig is the Pythagorean Theorem. This is something that you may have to use to find a missing side. And because when we're dealing with right angle trig, we're dealing with right angles, Pythagorean Theorem, or what we now know it as sum of squares, this can be applied to our triangles. So again, we have two different equations. One for finding the hypotenuse, that's the common one, a squared plus b squared equals c squared. And then for trying to find a leg or one of the shorter sides, a squared equals c squared minus b squared. A couple things to remember. A and b represent the two legs, and c always represents the hypotenuse in our formulas. A and B can be interchangeable because, again, the two legs, it doesn't really matter which one is which as long as we identified them as the legs. With right angle trig, there's three basic sides that we need to know in order to properly use our right angle trig. First is the hypotenuse. It's always opposite of your 90 degree, and it is the longest side of a triangle. The adjacent is based on the angle you're given or trying to find, and it is the side next to or beside your angle. If you're adjacent to something, you're beside it, so it's the side next to your angle. The opposite, it's also based on the angle you're given or trying to find, and it's the side across from, or in other words, opposite. So it's the side across from your angle, or opposite. So if we have a diagram here, x is the angle given, angle given or trying to find. So let's label our sides. Again, we see our 90 degree angle. So there's a couple things we could do. One, we could label directly across from 90 degrees is our hypotenuse. It is the longest side. It is across from 90 degrees. It is our diagonal. Across from the angle that's given to us is our opposite. And you could argue, okay, well, what's the last side? Or the side that's beside our angle? Are adjacent. So it is important that you know how to label these three sides because that's going to be key to using the right angle trig. And we see that with our trigonometric ratios. So you might have heard the term SOHCAHTOA before. This is kind of our acronym because we could say sine is opposite over hypotenuse. I'm just going to use short forms just to make it a little bit neater. So sine is opposite over hypotenuse. Cosine or cos is adjacent over hypotenuse. Tan is opposite over adjacent. So again, that's just a kind of a quick way to remember these, or your ratios. And again, we can see them here. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. So again, I'm just highlighting where we can see SOHCAHTOA. Now, if we're solving for angles, we want to make sure we remember that we are essentially doing the same thing, but we are dividing, or we are moving the sine over, or the tan or the cosine, which makes it the inverse or the opposite. Right? When we move something to the other side of the equal sign, it becomes the opposite. Same thing applies to sine, cos, and tan. So that's what that -1 means. It's the inverse tan, or the inverse sine, or the inverse cosine, not sine -1. So there is a specific button for that. So let's solve for the unknown. First thing we want to do is we want to label our sides. So I have my angle here. The side across from it is the opposite. I see my 90 degrees. Across from that is the hypotenuse. Next to my angle is the adjacent. So that's the first step, labeling your sides. Next, you're going to figure out which ratio are you going to use. And you do that by dealing with which sides you're using, or which sides you're given information for, or what side you're trying to find. So I'm given the hypotenuse and the adjacent. So if I go back to my ratios, the only ones that deals with adjacent and hypotenuse is cosine. So cosine theta is equal to adjacent over hypotenuse. Because I'm finding my missing angle, I should be given two sides, which I am. So cosine theta is equal to the adjacent, which is 12, divided by 17. I'm going to get cosine by itself by moving it over. It becomes -1 of 12 over 17. And I find that my angle is 45 degrees. One thing you want to keep in mind, you want to make sure that your calculator is in degrees. Right, so usually there's a button, it looks like either a D or a DEG. That's what you want your calculator in. You might see something like R or rads or radians. We don't want those. We want to make sure that our calculator is in degrees, not radians. Otherwise, you will get a different answer. Essentially, it's just a different measurement. It still means the same thing, it's just a different measurement. But we're going to stick with degrees. Next example. Again, let's label our sides. We see the angle we're given. We're dealing with then the opposite. We have the hypotenuse across from 90 degrees. The adjacent is right next to our angle. The two sides I'm dealing with, O and A. The ratio that deals with O and A is tan, TOA. So tan theta equals opposite over adjacent. Let's fill in the information. Tan 38, because theta is our angle, is equal to the opposite, which we don't know. I could replace that with x over the adjacent, which is 15. In order to solve for x, I need to move the 15 over to the other side. It becomes multiplying. So 15 tan 38 is equal to x. And when I solve for x, I should get 11.7. So that means that my opposite is 11.7 in length. One last example. Again, label our sides. Luckily, our angle is always has always been in the same spot, so it's still going to be opposite adjacent hypotenuse. Now, if this angle, so to speak, was moved over here, and this was 38, the only difference would be in the opposite and adjacent. These two would switch as well. The hypotenuse will always stay the same. It's the opposite and the adjacent that are dependent on the angle that you're given. So, I've identify my sides. Which sides am I working with? Well, I am given the opposite. I'm not given the adjacent, and I'm looking for the hypotenuse. So I'm dealing with the opposite and hypotenuse, which is sine. Sine theta equals opposite over hypotenuse. So sine 38 is equal to 25 over x. Now that I want to solve for x, this is the other situation we may come across. We can switch the two parts. I can switch sine 38 with x, and now I can solve. So 25 divided by sine 38 is 40.6. So that is the other type of procedure that you might go through. If our missing piece is on the bottom, we switch the two and then solve. Or if our missing piece is on the top, we bring the bottom up to the other side and multiply. So those are really the only two things that you might come across. Those are the only two kind of methods, that and solving for an angle like we just did here. So really those are the only three kind of methods that you will be using. Now the sine, the cosine, the tan might be interchangeable, but the steps are not. The steps are going to be one of those three steps. The next example, from a distance of 200 meters, the angle of elevation to a hot air balloon is 65 degrees. If the balloon is tied to a rope that extends straight up into the air, how long is the rope? And then would this situation exist? Explain. So a couple things to think about. First of all, means we have our balloon is tied to this rope here. So we're going to draw our little balloon. So maybe it might help if maybe sometimes drawing it makes it a little bit more exciting. So we have our little balloon here. We're going to draw some little lines in our balloon. So we have our balloon 200 meters away from our balloon. We use a ruler to make this accurate. 200 meters away. We have, or the angle of elevation. So all we know is that this is 200 meters away. It means the elevation to the hot air balloon. Angle of elevation means from a horizontal line up. So what that means is going from here up is 65 degrees. We want to figure out how long the rope is. So we want to figure out this value, this unknown. We are going to assume that it forms a 90-degree angle. So now let's go through and label our sides. We have our angle that's given, we have our opposite over here, we have our adjacent here, so that means, and we have our hypotenuse across from our 90-degree angle. We are working with the opposite and the adjacent, so that means we are dealing with tan. So tan theta is the opposite over adjacent. Tan of 65 is equal to an unknown value over 200. This means that the 200 comes up, and I multiply. To find my unknown value. And I get 428.9 meters. So the balloon is tied to a rope, and the rope is 428.9 or 429 meters long. So would this situation exist? You could argue no, that's a very long piece of rope. You can also argue that the rope or the balloon and the ground may not form a perfectly 90-degree angle. So generally speaking, would the situation exist? Probably not, but it could exist in some form or some variation, maybe not specifically a balloon being tied and extending straight up. But for all intents and purposes, we just kind of use that as an example to help us solve or use our trig ratios. From a 100-meter high cliff, a boat has an angle of depression of 25 degrees. How far is the boat from the base of the cliff? So this one's going to be a little different. We can draw our cliff here. We've got some grass, kind of then cuts down. Maybe we'll draw a little fence on the edge of our cliff. We don't want anyone walking off. So we have our cliff, say at the bottom. We then got our water. And we have a boat in the water. So let's just assume it's a little sailboat in the water, trying to get back to shore. We know that's a 100-meter tall cliff. Would we want to know how far is the boat from the cliff? And we are given that the angle of depression is 25 degrees. So the angle of depression is a little bit different from elevation because it's still from a horizontal. So if we imagine a horizontal line going out, the angle of depression then is 25 degrees. Downwards. We may have to move our boat backwards so that this actually works, because I did kind of draw it to scale, but you kind of get the idea. So say there. You don't need to draw yours actually to scale as long as you get the idea. So, but the key thing about the angle of depression is that this angle here is 25 degrees. So there's a couple things you could do. You could use what we see as the Z pattern. You could use that to then figure out that this angle down here is also 25 degrees. Or you could use the fact that we know that 90 minus 25 will equal this angle, or 65 degrees, because we can assume the horizontal line straight out and the cliff would form a 90-degree angle. We also have a 90-degree angle with the cliff and the water at the bottom. So there's different triangles you could use, or different angles that you could use to help us find this missing side at the bottom here, or how far away our boat is. So I'm going to use the angle that's given to us. I'm going to use this 25 down here. So that makes this the opposite, this the adjacent. Our diagonal here is our hypotenuse. The side I'm looking for is the distance from the cliff, or the base of the cliff. Drop my water back in. So that means I'm looking for this value down here, this adjacent. I am given the opposite. I'm looking for the adjacent, as I mentioned. So opposite and adjacent, O and A. I'm dealing with tan again. So tan is opposite over adjacent. So tan of 25 is equal to 100 over adjacent. Now that the missing piece is on the bottom, I'm going to switch tan 25 with the adjacent. And when I go through and solve, 100 divided by tan 25, I get 214.5 meters. So that means that the boat is 214.5 meters away from the cliff. So again, this should be a review. The biggest thing is being able to identify and label those three key sides, the opposite, the adjacent, and the hypotenuse. Once we can label those sides, we can then hopefully figure out what is the correct ratio we need to use, sine, cos, or tan. Once we plug it in, there's one of three things we're doing. We're solving for an angle, which is relatively straightforward. We are solving for the missing piece on the top, which means, similar to this example, we bring the bottom number up and we multiply. Or the third possible method or situation, the missing piece is on the bottom, which means we switch them, the bottom and the tan theta or the ratio and the angle, and then we end up dividing. So those are the three situations that you may come across. We see one here, and all the way back up, we see one here. So again, this should be a review. So if it is not, or if you do forget this, please make sure you are going through and practicing. But again, remember those steps. Label the sides, figure out the correct ratio, figure out which procedure you're going through based on what you're trying to find.